In this video, we are going to talk about an arithmetic series. An arithmetic series is a sum of terms of an arithmetic sequence. There's a formula to find the sum of terms of this arithmetic series, which is S sub n equals n over 2 times a sub 1 plus a sub n. We know n is the number of terms, a sub 1 is the first term, and a sub n is that desired term, or usually the last term. So in this first example, we have a cross-stitching of a house. The roof has 5 rows. The first row has 5 stitches, the third has 9, and the fifth, which is the last row, has 13 stitches. We need to find the total number of stitches on the roof. Well, according to our formula, we need to know what n is, which is the number of terms, which is 5 in this case. A sub 1 is the value of that first term. The first row we know has 5 stitches. And then the last row, the fifth row, a sub n, has 13 stitches. So now I can plug these into my formula and figure out what the total number is. It's going to be S sub 5 equals 5 over 2 times the first term plus my last term, which gives me a total of 45 stitches. That's it. Summation notation. This is new. You may not have seen this before. This is a sigma. In your sigma, you always have usually n equals 1. This is your lower limit. Sometimes it says n equals 2, things like that, and I'll explain what that is in a second. And then above here on the top of the sigma, you have your upper limit. And then in the middle, you have your explicit formula. The lower limit is the first value you plug in for n. Ooh. That means your upper limit is going to be the last value that you plug in for n. My stylus is not behaving today. Alright, something that's really important is that these upper and lower limits, and students confuse this a lot. The upper and lower limits are not the term numbers. They're just what you plug in to get the first term and the last term. And in the examples that follow, I'll be able to give you an example of what I'm talking about. So remember, they are not the term numbers. They are the values of n. That go in the formula. And the last thing that you need to know that students also mess up often is that to find the number of terms, you're going to take the upper limit minus the lower limit and then add 1 to it. And again, in the examples that follow, you'll be able to see this. So in this first example, we have a summation notation, the sigma. We have our lower limit of k equals 1. Our upper is 35. And then we have our formula, the 5k minus 2. So if I have to evaluate this, that means I have to find the sum. Remember, to find the sum, we're looking at S sub n equals n over 2 times a1 plus an. So I need to know what n is, the number of terms. Well, to get that, remember, you take the upper limit, which is 35, minus my lower limit, which is 1, and then add 1 to it, which is 35. Now I need a sub 1, my first term. To get my first term, remember, I'm plugging in the lower limit into my formula. So that's going to be 5 times 1 minus 2, which is 3. So my first term is 3. My last term I find by plugging in the 35. So 5 times 35 minus 2 is 173, which is my last term. So now I can plug this into my formula. I know n is 35 because I have a total of 35 terms, equals 35 over 2 times my first term plus that last term, 173, the 35th term. If you evaluate that, the sum of those 35 numbers is 3080. We'll skip B for now. I'm going to jump to C just so you guys can compare it to A. If you look at C, you'll notice that your lower limit starts at 2. So again, that doesn't mean that I'm starting at the second term. It means that my first term is found when I plug in a 2. All right, so A sub 1 is found by plugging in that 2 into the formula for K. So that means A sub 1 is 17 in this case. A sub n, the last term, is found by plugging in that 10. So you get 73. Now you might say, well, isn't the last term A10? It's not. Because, remember, to get the number of terms, I'm going to take my upper limit minus my lower limit and then add 1 to it, which gives me 9, which means I actually only have 9 terms. You can see that because I started at 2 rather than starting at 1. So I have a total of 9 terms in this case. So when I plug this into my formula, I'm looking at S sub 9 equals n over 2. Again, n is 9 in this case. So 9 over 2 times the first term, which I got by plugging in the 2, plus my last term. So the sum of those 9 numbers is 405. Alright, so let's go to B now. B is rather involved because we got to do a couple of things. First, we have to write this in sigma notation. So you have to think, okay, what do I need for sigma notation? I need an upper limit, a lower limit, and a formula. The upper and lower limit are pretty simple to find. I'm stopping at 16 numbers, so that's going to be my upper limit. So the formula is the explicit formula for an arithmetic sequence. So that means you have to remember what that is. That's a sub n equals a sub 1 plus n minus 1 times d. So a sub n, I need a general formula, so I'm not going to plug the 16 in for n at all, because I need a general formula to find for any term number I need, whether it be the 10th number or the 12th number or whatever. So this is just going to say a sub n equals my first term, which is 20, plus n minus 1 times the difference that you can see is 7. Now I can distribute the 7 through. So I get a sub n equals 20 plus 7n minus 7. So I get 13 plus 7n. So that's the formula that I'm going to plug in to my sigma notation. So 13 plus 7n. My upper limit is 16 because, again, that is the last number that I'm plugging in for, and I'm starting at the first term. I'm not starting with finding like the second term, right? 20 is the first term in this series, so that's where I'm starting with. N is 1. When I plug in this n is 1, you will get 20. Okay, so again, that's that reminder to you that these upper and lower limits are not the term numbers, they are what you plug in to get the term that you need. Alright, so we have our sigma notation and now we have to evaluate. Okay, well, to evaluate, we need to remember that we have to find our number of terms, our first term, and our last term. Well, we know our first term is 20. We already figured that out. They gave that to us. And you can figure it out by plugging in that n equals 1. Okay, if I do that, again, a sub 1 is 20. To get my last term, I'm plugging in 16. It's 125. N is going to be 16 minus 1 plus 1. So that means I have 16 terms. And then I can plug this into my summation formula. So S sub 16 equals 16 over 2 times my first term plus that last term. You get a sum of 1160. All right, last one, part D. So I need to find the number of terms. They give me the first term, the last term, and the sum formula, or this what they sum to. So I'm going to use the sum formula. So 690 equals n over 2 times the first term plus the last term. First thing you're going to do is multiply that 2 over, which gives me 1380 equals n. 19 plus 96 is 115. Then you can divide the 115 over. You get 12. So that means there are 12 terms in this arithmetic series. That's it for arithmetic series. Let me know if you have any questions.